This problem is similar to homework 2, problem 10, in which we have a gun pointed horizontal towards a target 100 meters away. You see that the bullet hits the target 5 centimeters below the aim point. What was the bullet's flight time and what was the bullet's speed as it left the barrel? The time of flight and muzzle velocity. And so we'll draw the gun. This is going to be our origin, 0.00. Let's go ahead and label that. We know we've got some initial velocity, vi, and we know it's in the x direction, so there is no x and y component. All of vi is the x component. We travel 100 meters away near the target, and this is our aim point. We know that it hits 5 centimeters below that. This is 100 meters. And so we want to get rid of that centimeters, right? So how do we convert 5 into meters? Well, we divide by 100, 0.05 meters. So to figure out the flight time, well, we're working with 2D kinematics again. And the best solution method for two-dimensional kinematics is just to go ahead and write out the position equation for both the x and y directions. And the position equation is x equals x initial plus v initial times time plus 1/2 a t squared. And so in the x position, our initial is 0. Our initial in the x is vi times time, and there's no acceleration in the x-axis because we are in free fall. Our y position, once again, no initial position because we started 0, 0. There is no initial y velocity, but we do have negative 9.8, our a, divided by 2, times time squared. So when we look at our problem, we have an x of 100 meters. So we know we're going to be plugging that in there at some point. We have a y drop of 0.05 meters. So why don't we plug those two values in? 100 equals v initial times time. And then we have 0.05 equals 9.8 over 2, negative. And then we have negative 0.05, right? If that 0.05 was not negative, we would end up finding a negative t kind of thing. And that's not going to work out. We have a negative in the square root. We have to make sure that if our acceleration is negative down, this displacement is negative down as well. Now we see here, we have two unknowns in our x equation, so we can't solve that yet, but our t equation, right? We can solve that, because t is our only unknown variable. And so we can move this negative 9.8 over 2 to the other side of the equal sign. We get t squared equals 2 times 0.05 divided by 9.8. We're just multiplying by the reciprocal. And then t is the square root of both sides. So t is 0.101 seconds. It's a pretty long flight time. So now that we have time, we can go ahead and plug that into our x equation. 100 equals v initial times 0.101 seconds. We find v initial to be 990 meters per second. So for part A, it asks us to find the flight time. That's going to be our 0.101 seconds, or 101 microseconds. And we have our initial velocity of 990 meters per second. And that completely answers this problem.